and welcome back to class of Design of Machine Elements. I am Hitesh Raiyani, Assistant Professor at LJ Institute of Engineering and Technology. This is Lecture 8, Example of Fluctuating Load. The learning outcomes of this lecture is to learn the example of finite life based on the reversible law. In previous lectures, we learned the different factors K, KB, KC, KD, how to calculate the K, KB, KC, KD, and what is the AC dash and relationship between AC and AC dash. So now we have to use these all formulas to solve the problem based on the fluctuating load, which is for the infinite life. So we will start one with for examples. So consider one examples. A plate made of steel 20C8 SUT is equal to 440 Newton per mm square in hot roll and normalized condition is shown in figure. So here you have to given the plate steel plate 20C8 and SUT value of steel plate is 440 Newton per mm square. Plate is made by hot roll and normalized condition is shown in figure. So here you can see in the figure there are plus or minus 30 kilonewton load is applied and the width of the plate is 50 mm and there are central hole of diameter 10 mm. Now it is subjected to a completely reverse axial load of 30 kilonewton. So plus or minus 30 kilonewton is applied at the end of the plate. The notch sensitivity factor Q can be taken as 0.8 mm, 0.8 sorry. So value of Q is given, it is 0.8 and the expected reliability is given 90%. So R is given 90%. The size factor is 0.85. As we know the size factor is KB, so KB value is given and that is 0.85. The factor of safety is 2. So determine the thickness of plate for the infinite life. So we have to calculate the plate thickness for infinite life. So here according to this configuration we can be clear that the problem is based on the infinite life and the load is applied that is fluctuating. So it is completely reverse axial load. So we have to design this plate for infinite life. So we have to use the endurance limit to calculate the thickness of plate. So to calculate the endurance limit of these particular situations or particular geometry, we have to first calculate the AC dash. Before that, we collect the data given. So according to this problem, the data given is P is plus or minus 30 kilonewton, SUT is given 440 Newton per mm square, factor of safety is 2, reliability is R is given 90%, Q is 0.8 and KB is given 0.85. So we have to first calculate the AC dash. So AC dash is we have a approximation formulations between AC dash and SUT according to the material. So here the material is steel and we know the for steel that is AC dash is equal to 0.5 into SUT. So we have to place the value of SUT to get the answer of AC dash. So we will get the AC dash is equal to 220 Newton per mm square. Now we have a value of AC dash. What is our aim? Our aim is to calculate the endurance limit of this particular plate. So we have to calculate the AC and we know the equation of AC is Ka into Kb into Kc into Kd into AC dash. Now we have a value of AC dash. So we have to first calculate all the factors value. So first we start the surface finish factor Ka and we know the surface finish factor is the function of machining operations and the ultimate tensile strength. So here the condition is hot rolled steel and SUT is 440 Newton per mm square. So for these conditions we have to calculate the surface finish factor Ka and for that we have to use this chart, surface finish factor chart. and you can say that there is x-axis, there are ultimate tensile strength, and you can see the different curves according to the manufacturing operations. So here the condition is hot roll, so we have to follow the curve of hot roll, and the ultimate tensile strength is given 440 Newton per mm square. If we convert into GPa, that is SUT is 0.44 GPa. So to calculate the Ka, we have to draw the vertical line 8.44 SUT value, and we have to extend this vertical line up to the hot roll curves. And from intersections of this curve, we have to draw the horizontal line to calculate the value of Ka. So we get the value of Ka is 0.67. So according to this configurations, value of surface finish factor Ka is 0.67. Now next is Kb, size factor. As we seen in the problems, the Kb is given, size factor is given, so we have to take Kb is equal to 0.85, that is given in problem. Next is the reliability factor. So reliability factor Kc. So reliability condition is given, there are 90% reliability. So for 90% reliability, we have to calculate the reliability factor Kc, and for that we have to use this table to calculate the value of Kc. Here the condition is 90%. So according to 90%, the value of Kc is 0.897. So we can find the value of Kc according to the reliability percentage. Next is the Kd. So to calculate the Kd, as we know the equations of Kd is equal to 1 upon Kf. So to calculate Kd, we first calculate the Kf, and equations of Kf is 1 plus Q into Kt minus 1. Q is the notch sensitivity factor and it is given in problems, and Kt is the stress concentration factor. So to calculate the Kf, we have to first calculate the stress concentration factor for the plate has a central hole subjected to axial load. So for that we have to use the stress concentration chart, and if you seen that in stress concentration chart, to calculate the value of Kt, you have to first calculate the ratio of small d by W. So first we have to calculate the ratio small d by W. So according to our condition, small d is 10 and W is the width of the plate, it is 50. So small d by W ratio is 0.2. So now we have a value of small d by W ratio is 0.2. So to calculate the value of Kt, we have to draw the vertical line at 0.2, and from the intersections of these curves, we have to draw it horizontally to get the value of Kt. So it will be 2.51. So Kt is known and Q is given. So we can calculate the Kf, that is 1 plus Q Kt minus 1. So by placing the value of Q and Kt, we can find Kf is equal to 1 plus 0.8 into 2.51 minus 1. So Kf value we get 2.208. Now we have a value of Kf. So Kd is 1 upon Kf. So we can calculate the value of Kd is equal to 1 upon 2.208. So we get the value of Kd is equal to 0.4529. So now we have a all value Ka, Kb, Kc, Kd and Ac dash. So we can calculate the value of Ac. As we know the equation of Ac is equal to Ka, Kb, Kc, Kd into Ac dash. So value of Ka is, so by placing all this value we can get the Ac value, that is endurance limit. So Ka is 0.67, Kb is given 0.85. Reliability factor we calculated from the reliability table. So it is 0.897, and Kd we calculate in previous slide, that is 0.4529, and Ac dash is 220. So Ac value we can get 50.9 Newton per mm square. Here the condition is axial load, and we know that for axial load, ACA is equal to 0.8 into SE. So we know now the value of AC, and AC is the 50.9. So by placing the value of AC, that is 50.9, we get the ACA, that is 40.72 Newton per mm square. Now we have to calculate the permissible stress amplitude, and permissible stress amplitude, that is sigma A, is equal to SEA divided by factor of safety. Here the factor of safety is given, so we have to consider it, and for that sigma A becomes SEA divided by factor of safety. SEA is 40.72 and factor of safety is 2. So by placing this value, we get the sigma A, that is the permissible stress amplitude, is equal to 20.36 Newton per mm square. Now we have to use the elementary equations to calculate the thickness of plate. So according to this given geometry, plate has a central hole and subjected to axial load. So we have to use the tensile load permissible stress equations for the calculations of plate thickness. So sigma 0, that is the elementary equations, that is equal to P divided by W minus small d into T. So now we have all the value of P is 30 into 10 raised to 3, W is given 50, small d is 10, and sigma A is 20.36. So only unknown is T. So by placing this all value and to calculate by simplifications of this equation, we get the value of thickness T, that is 36.84 mm. So in this way you can calculate the thickness of particular geometry for the infinite life problems. Once you have to keep in mind that whenever the problem is based on the infinite life problems, you have to consider the endurance limit to calculate the design parameters. Here T is 36.84 mm. So if you take the thickness of plate, T is 36.84 mm, then the plate sustain at least 10 raised to 6 number of cycles, means the plate sustain infinite life of cycles. Thank you.